The views and opinions expressed in this program are those of the speakers and do not necessarily reflect the views or positions of any entities they represent. This program is intended for educational purposes. आप सुन रहे हैं रेडियो अजीम प्रेमजी यूनिवर्सिटी।
Hello and welcome to It's a Math World. We are traveling to Japan with Professor Divakaran. Hello, Professor.
Hello everyone.
It's a Math World with Divakaran and Shraddha. Episode 4. Number Origami.
So I think probably all of us know that Japanese are fascinated with paper. Like they use paper to make umbrellas, they make paper to form partition between different rooms and so on.
Their chapati is rice paper. Yeah.
So they are really obsessed with paper. They are also interested in making different shapes using paper, and sometimes there are myths associated to it. I think all of you are familiar with this thing that if you make 1,000 cranes, then your wish will be satisfied.
Oh, if you make 1,000 origami cranes.
So I think the origami crane is a very popular thing. I think it originated from this. There was this one sick girl, like a small girl going through some really bad this thing. So then, and she had this belief that if she made 1,000 cranes, then her illness will get cured.
All right.
So, but she had very little time in her life. So people all started making cranes for her. So that it kind of became like, let's all pitch in and make the crane. I think the kid died. That was the unfortunate part. After that, I think this idea of making 1,000 cranes became popular in Japan. Whenever they had some wish, they will make 1,000 cranes. So it became like a contract of that sort.
Doesn't sound like a very eco-friendly belief. However, it's rather cute making these origami cranes.
Yeah.
Wow.
So if you want to, like, you also make and gift it to others and things like that. So
right.
Of course, anyway, long story short, people were obsessed with making various
Shapes.
3D shapes
using
paper.
But what does the word origami really mean?
So ori means fold and kami means paper. Of course, the word kami with different intonation can mean different things. Kami can also means hair. Kami can also means God. Kami can mean paper.
Okay.
There are various meanings. So ori means fold and kami means paper. Just like in South Indian languages, ka when comes in between becomes ga many times.
Oh,
So ori plus kami is origami.
Origami. Okay.
The obsession of origami is making shapes. Finally, we are making shapes from a piece of paper, which is kind of planar.
2D.
Which is 2D. Imagine this thought experiment. Suppose you don't know how to make a plane. I make a plane using a piece of paper, then unfold it. And I give it back to you. I believe you will be able to fold that plane without knowing how to fold it. Because there is a memory of how it was folded that is left in this paper.
That might be very true for paper planes, but not for Kanjeevaram sarees. How many times have I been told, do not open it, you're not going to be able to fold it back. And I've said, of course I will, because I can see the lines. And then no matter how I do it, it is wrong. Oh, yes. Much easier for a paper plane.
Exactly. So if you have a crease, then and also the crease tells you which way it was folded.
Right.
Whether it was folded towards or whether it is folded away from you. So this information is also clear from the crease itself.
Yeah.
So because of that, you will be able to follow that memory and construct the 3D object without knowing how to construct the 3D object.
Absolutely.
So what we can understand from this idea is that even though our goal is to construct 3D objects, it's enough to understand what kind of crease pattern we can construct on a piece of paper. Let's say it's a chair. Then what can you understand? You know that the chair should have 4 legs. That's the main thing, right? That's the first identifying feature. So there will be, how do you draw a stick figure or whatever of the chair? There should be one plane, then from there 4 sticks should go down.
And one more plain backrest.
One more plain backrest should be there. This is the kind of stickish figure that you can construct. Once you have constructed this stick figure, algorithm automatically draws the crease pattern. And the crease pattern also tells you whether you are folding towards you or away from you. These have formal names in origami. They are what are known as valley fold and mountain fold. Okay, so valley, because valley is folding towards you, because then there is a, like, it's like a dip. Away from you is called mountain fold because it looks like a peak. So it's called valley fold and mountain fold. So you have to also clearly tell which are valley folds, which are mountain.
Or the chair will have legs going upwards.
Exactly. The directions and all will not be proper. So this algorithm is called tree maker algorithm. It automatically constructs this crease pattern. Now, once this crease pattern is constructed, just like how you could construct the plane from the memory of the paper, you can similarly construct the model that you wanted to make.
Which means that now the algorithm has created the crease pattern.
Yes.
If I print it out on a piece of paper, it also tells me which is a valley fold, which is a mountain fold. I just fold it that way and I have a chair, origami chair.
Exactly.
Wow.
So that's the beauty. Of course, practically folding it will require some amount of practice, so it's like this, right? Even if you know how to do it, sometimes doing it requires some form of skill practice and things like that. So those things obviously will be here in any art form.
And that is why none of the recipes, YouTube recipes, turn out the way it looks in the video.
Exactly.
Ever.
Exactly.
Right.
So what have we learned here? Even though our goal is 3D objects, it's enough to understand crease patterns. And what are these crease patterns? They are basically only lines. Now, the next important thing to understand is drawing lines is simple. Drawing lines using a folding paper is simple. As soon as we have identified 2 points, I can make a fold that passes through those 2 points.
Right.
So, constructing 3D objects is equivalent to constructing certain points. So, if I want to ask the question, can I construct a particular shape? I'm actually asking, can I construct certain points using the operations of origami. And this is similar to the questions that Greeks were asking. What kind of points we could construct using a scale and compass?
They had the scale and compass, Japanese had the paper.
Exactly. That's the only difference between that, and the question is analogous. Sometimes the Japanese were happy with approximations because they were more interested in the final object than the deep mathematics behind it. They had some interest in it, but not as much. But later mathematicians in more recent times have been really obsessed with the mathematics behind these things. Asking questions that are analogous to the questions that the Greeks had asked.
So when the Japanese were making these origami art, did they know that there's so much math in it?
This is very interesting, according to me. So there are certain base forms that they make with which they can make more complicated shapes. So for example, there is kite, there is frog, there are these 5-6 basic constructions using which they are like building units from which you can make a lot of other more complicated structures.
Yeah, so this is a lot like Lego.
So no. Here they are not constructing different pieces and uniting them. That is also a form of origami, which is called modular origami. Typical origami, you are constructing using one piece of paper. So you are not allowed to combine multiple pieces of paper.
Right.
You are only allowed to construct something using a single piece of paper.
Right.
But within that single piece of paper, suppose I want to make a kind of pattern, like crease pattern kind of thing I want to make. So they will say, oh, you first do this, then do this, then do that. Right? First make the kite pattern. The moment you say first make the kite pattern, people understand that. Then make the fish pattern in this part.
Oh, now I'm getting it. Oh,
right? So this is how they would communicate.
Oh, so I make the kite pattern, I open it up.
Yes.
Now, on the top right, make the fish pattern.
Exactly. Something like that they will tell you.
Bottom left, make the frog pattern.
Something like that.
Oh, and now when you fold it all together, you will get this shape.
Something of roughly this is the idea.
Oh, okay.
So the idea is there is this global complicated folding that you have to do. That complicated folding is reduced to these simpler folds that they're all very comfortable with. So you have to only tell what those simple folds are. right? The complicated. This is the whole idea, and this is a mathematical idea according to me. A number can be expressed as a product of prime numbers.
Correct.
So a complicated number is now reduced to prime numbers. If you understood prime numbers, you understood everything.
Correct.
A complicated construction is reduced to understanding some basic constructions.
Correct.
So that is itself a mathematical idea.
Ah.
So there were many of these mathematical ideas that the Japanese original origamists were themselves occupied with. But not all of the questions that are currently related to origami were questions that the origamists were interested in.
So then if they are not trying to answer a mathematical question using origami, what was the inspiration to delve into more complex shapes for them?
So they were interested only in the aesthetics of it.
Oh, really?
They were really into the aesthetics, but somehow aesthetics and maths cannot be separated.
Correct. Just like music and maths cannot be separated.
Exactly.
Yeah. Oh, wow.
So, and this comes in various places. Like the Islamic art is a rich place where lot of interesting geometry comes in. The wall art in this Alhambra is very famous for the kind of fascinating geometric patterns that they have created.
Yes.
And it uses deep mathematics. Like we can understand it using deep mathematics. Appreciate the beauty more if you understand the mathematics behind it.
Right.
But of course, probably they did not care about the mathematics. They were interested in the aesthetics of it.
Correct. So similarly, the Japanese were actually trying more and more complex levels of origami just to see, how much more prettier this can be.
Exactly.
Oh.
So they probably were interested only in the aesthetics of it. But if you want to do this, you need to understand the mathematics to some extent. If you don't understand the mathematics, you probably cannot create beyond a particular level of complexity.
No, it's beautiful how math followed art over here. Right?
And actually, there is a lot of different cases where maths follows from art. It's not, of course, we have this misconception that maths is like made to sciences, which is not always true. Of course, math has helped sciences a lot, but it's not always the case.
Right.
It comes everywhere.
But after they realized the mathematical secret or the mathematical foundations or the mathematical concepts in origami, did it help make their origami better?
Absolutely. So in fact, like this Freemaker algorithm is like a huge leap in the kind of things that you can make using origami. Now there is no comparison with what could have been made earlier and what can be made right now.
So today, using the Treemaker algorithm, the kind of origami shapes you can make will totally baffle the fathers of origami in Japan.
We have suddenly jumped like many levels beyond. It's really, the maths has really made a significant contribution to the kind of shapes that you can construct using paper.
Using origami.
Yeah. So that's always the case with mathematics, right? Like there are people who are only interested in the theory of it. But it still contributes in ways that even like probably the original thinkers did not even care about.
Right. But was there a point, would you know about the point where they realized, oh my God, there's so much math here, or this is math, like,
Yes, there was.
Oh, okay.
They suddenly got interested in the maths and people started talking about the maths behind origami. And nowadays there is a lot of talk about that. There are a lot of books on mathematics of origami and how it can be understood. There are a lot of books about it.
Hi, I'm Giri.
And I'm Raghu.
So Raghu is 77 and I'm 67. And we've been following cricket like mad for the past 60 years.
I learned the English alphabet spelling Umrigar and Hazare and Mankad. So the first test as an Indian team which we played was well before we got our independence in 1932.
Governor Raja Maharaj Singh joins thousands of eager spectators.
The whole story changed in 1961-62 tour because Nari Contractor was felled by a bumper from that dubious bowler called
Charlie Griffith.
Charlie Griffith, known as Charlie Chaka.
So Charlie Griffith has struck again.
By the time the 1980s began, the spin quartet had gone. Kapil had arrived and India had a pace attack for the first time in its cricket history.
पाकिस्तान के मुकाबले में ये पहली विजय प्राप्त हुई है. कपिल देव को मैन ऑफ द मैच चुना गया.
The inflection point is the 90s. Doordarshan would go say, can you please show this match you now had people saying, can we host your match? The money started coming from there.
Some of the most amazing things that have happened in the last decade, which includes women's cricket, media, analytics, and the way the game has changed in this last decade.
In Well Caught by Raghu and Giri, hopefully you'll get a sense of how we must have fought and discussed and come together to write our books.
Oh, brilliantly caught. Absolutely magnificently caught by...
Well Caught with Giri and Raghu. Out now. Only on Radio Azim Premji University.
But what has understanding the mathematics of origami helped in modern applications?
So the tree maker algorithm, for instance, uses a lot of these mathematics, very deep mathematics behind origami. Without that, you could not have come up with the tree maker algorithm. I have put the algorithm itself under the rug. That's why you don't see where that is coming from, right? But the algorithm is very deep, very complicated, and you could not have done that if all this mathematics was not developed by various people.
Now, we spoke about how origami was driven initially only by aesthetics.
Correct.
But now that we have math, has origami moved beyond aesthetics?
I think still to some extent, most people who are fascinated by origami are driven by aesthetics. But now there are mathematicians. Like, for example, this is something that I find very fascinating, right? Many people, there are both ways. So origami people have started reading maths because of this. And there are people like me whose interest is not in origami at all. But I am interested in mathematics. But I have started studying origami because there is maths in it. Right? Now, when I study the origami and mathematics, my interest is not the aesthetics bit.
Right.
My interest is in the mathematics bit, and I feel there is aesthetics within mathematics.
Right.
So it's the aesthetics of the mathematics behind it that attracts me to it.
Right.
So people like me will not be interested in the aesthetics of the shapes that you can construct with paper.
Right.
But the aesthetics of the mathematics behind these constructions.
My God, you are like the chartered accountant or the venture capitalist in show business. I am not interested in the art, but just the numbers. Do you see any modern day technologies that have taken inspiration from origami?
So there are several actually, several technologies that have used the ideas that come from origami. One of the big things is there is this particular way of folding paper called Miura folds, which actually had deep applications, many applications.
But tell me about the Miura fold.
So the Miura fold is a special kind of fold. The property of this Miura fold is the following. Typically what happens is when you fold, like suppose you fold a boat, for instance. You open it. Again, folding it is not easy.
Correct.
Right?
Correct.
You can do it, but it's not easy.
Not easy, yeah.
Here in the Miura fold, what happens is there is some direction. So I have folded it. By just pulling it in one direction, it unfolds itself. And then when we push it back, it folds it again.
Oh.
There is one particular axis by which, over which if you pull it or you push it, it folds, unfolds, folds, unfolds.
Oh, this is like that musical instrument.
Yes, harmonium kind of thing.
What is that thing called?
Harmonium, right?
The accordion. This is like the accordion, right? You can just fold it and unfold it.
Yeah, but here it's like, it folds really. It's not, so the accordion is folding only in one direction. Here it's folding like vertically and horizontally in one shot.
Oh!
So it's even more fascinating than what is the accordion manages to do. So it can make it really compact. So very large sheets can be folded into something very, very compact. And this was used to sheets that was used for making mirrors in telescopes and things like that. And this had to be sent on a satellite. So what did they do? They used the Miura folds to fold it, then sent it using a satellite, and then once it reached there, they unfolded it. Now it can be used for making a telescope and things like that.
Do you think that in Japanese schools, they're using origami to explain mathematical concepts to children?
I am not very sure about that. I do think that almost everybody in Japan learned some amount of origami. How much of that is being used to teach mathematics, I don't know as much. but they certainly learn origami. Origami is part of their culture.
But beyond aesthetics, how important was origami to just Japanese culture? I mean, if you really go back in time. And right now, if I think of origami from an aesthetic point of view, it could just be something somebody did as a hobby and made, let us say, a tulip or a rose and then kept it at some corner of their house to sort of say, now it's looking pretty. But do you think there was any bigger significance to origami than just this as a hobby?
It's, how do I say it? It's like they really treated it more as an art form than as a hobby.
As a hobby.
How do I say? It's like, of course, there are people who did it as a hobby, but it was a way more than that for a lot of people. So for many of the people, it is really a deep art, and they did very, very complicated stuff with it. And so it's like this, right? Of course, you can do drawing as a hobby, but you can also do drawing in a much deeper, much more passionate, in an artistic way, and you can go as deep as you want.
Right.
So first of all, the depth to which people went was huge.
Correct.
That is one thing in which I think maybe Japanese did it in a way that is deeper than what people in India would be taking. People in India take origami maybe not as seriously as they take it.
Right.
More importantly, it also had some cultural significance in their day-to-day life.
Right.
Like, for example, the crane, the paper crane that they make, there are some beliefs surrounding around making paper cranes and things like that.
Do you think there are still things that origami can teach us about mathematics or mathematical models that are yet undiscovered?
Very likely, I would say. I think, certainly, I believe that when we start looking at things deeper and deeper, you probably will learn better and better. So this is something maybe I will tell you, this is some story that I find very fascinating because you asked this question. I think it's about how we look at things can I think I will first tell the example because the example really captures what I want to say. So there is this linguist called Daniel Everett. So I find his book called Don't Sleep, There Are Snakes very fascinating. It's a story. He actually was a church linguist. What do church linguists do? The church sends them to new areas. Once they go to a new area, they go there, they interact with the local people, learn the language, translate Bible into that language. That's their job.
Right.
Okay, so these are what are known as church linguists. Their ability is learning new languages with by only interacting with them. There is no translator, nothing. You go talk to them, somehow understand what they are saying, learn the language and translate it. And these are, I'm talking about tribal people in Amazons and stuff like that, who have no clue of any other language. He has traveled many places, and particularly this book is about his experience in the Amazon, one tribe in Amazon. So he says that one of his experiences he says was very fascinating for him, which is the following. These tribal people, they all know that he can speak their language. The language is Piraha. The community is also called Piraha. So they know that he can talk Piraha. But they will do this. They will come to him and say, ask, Daniel, can you give us so and so? Then he will say, yes, I will do this. Then he will turn to the person who is asking this, will turn to his tribe mates and say, haha, I will cheat Daniel, I will pay him less or something like that in their language. Then he will come, he will talk to him as if he doesn't, they talk to others as if he does not understand, and then talk back to Daniel in Piraha only, not in any other language. But he's still, it's like they're assuming that he will not understand whatever he is talking to his other tribe members.
When in fact they are conversing with him in the same language.
Exactly. And he couldn't fathom why this is how they can do this. How can they talk in his presence as if he doesn't understand what they are talking about while they are conversing with him in the same language.
Like if this was a conversation between two 5-year-olds, it's understandable.
Exactly.
They're so innocent. Are in front of me only you're saying this. But these are fully grown people.
Exactly. So this was the first shock for him. Another incident, what happened is that these are heavy meat eaters, right? Tribal people, heavy meat eaters. And he was in the jungle. He was missing salads. So once in a while, there are these planes come and drop food for him, the food that he likes. He's an American, the kind of food that Americans like. So he told that I want salads. There are greens. I like greens. Please drop some greens. Next time you come, drop some greens. So they dropped greens. And he was eating this. Then he was eating that. While he was eating that, this one Piraha person comes in and he sees him eating these greens. He's like, why are you eating grass? Then why are you eating grass? I have meat with me. I can give it to you. Don't worry. You don't have to eat grass and all that. I have a lot of meat. I will give it to you.
This is how all non-vegetarians behave with vegetarians anyways. Why are you eating grass?
So then then he said, no, I like it. Then the person says, this is why you will never learn our language. Because you don't eat like us, you don't behave like us. That is why you can never talk our language.
Huge shout out to all my non-vegetarian friends. Y'all have not changed.
So this, but he interpreted it differently. Of course, we would have just dismissed this off. This is some nonsense. This is some racist comment or something like that. That's how we would have dismissed it. Daniel Everett did not dismiss it in that way. What he thought is, he interpreted it differently. He said that, he actually thought that probably what they believe is language is not just what we are speaking, but it is also the culture and it is much deeper than... So being able to speak the language is not enough. You have to be embedded into the culture.
Correct.
Without that, you don't really understand the language.
So even though you've learned the grammar and the vocabulary, you're not one of us yet.
Exactly.
And that's why I will talk to you in this language and yet talk to my people in the same language, believing you don't get this.
Exactly.
Oh.
So unless you have understood our culture, you live like us, you eat like us, you do everything like us, you are not really understood our language. You will understand our language only when you have understood our culture, you live like us, you eat like us and everything. He interpreted it that way. And in fact, he actually gives us an example. Daniel says that, see, the Amazon forests are filled with parakeets who will repeat whatever you say. So how is the Daniel any different than parakeet? Maybe that's what they are thinking.
Right.
Do you think that the parakeets understand your language?
No.
But they can repeat. They can repeat whatever you are saying. But the parakeets don't understand your language. Daniel is no different than parakeets. Maybe that's what they are thinking. So I found it fascinating because there is this joke in one Malayalam movie which is somewhat related. So there is this, I had earlier quoted this as an example that correlation is not causation in some place and stuff like that. So this is, in the movie, like the Malayali guy is in a Hindi family. So and they say something and he does not understand. So one of the things that he responds is, I don't eat chapati and therefore I don't know Hindi. ഞാൻ ചപ്പാത്തി കഴിക്കാറില്ല അതുകൊണ്ട് തന്നെ എനിക്ക് ഹിന്ദി മനസ്സിലാവൂല്ല. So the thing is, like, of course there is a correlation between that. Chapati eating and Hindi, there is a correlation. But it's not a causation, it's something that we understand and we make fun of it.
Right.
So I was joking that I made fun of him when he said that, but Daniel Everett did not make fun of the Pirahas when they said something very similar.
Correct.
You are not learning Piraha language because you are not eating like us. He thought deeper. And because he could think deeper, he could learn more. So coming back, why did I again take all this detour? What we can still learn from origami, we never know. We probably will understand it when newer and newer ways of thinking can probably... So I would say that try to be as open as you can and then keep looking.
Yeah.
You might get something or the other.
And try to color yourself as deeper as you can in that color. Like probably if you look at origami the way Japanese art lovers did, from your knowledge of mathematics, maybe something very, very beautiful will bloom out of the union of these two.
Exactly.
Right?
Make sure you check out the show notes where we share the show resources and acknowledgements. And don't forget to subscribe or like our channel for future episodes. आप सुन रहे हैं रेडियो अजीम प्रेमजी यूनिवर्सिटी